Right. Hello everyone. My name is Rishabh Pandey and I'm a physics faculty at askIITians. Right. So basically today we are going to cover electric current, you know, and its effects. This is the very first lecture of this chapter and we'll be covering the basic introduction points and a bit detailed version of it. Right. Say the topics which are to be covered is we'll be talking about the introduction of the flow of the currents, that how basically the currents flow in a circuit. What are the components of the circuits? Battery, switch, bulb, all these the components of the circuits, and the symbol of those components. And I will be talking about these basic points in this lecture, starting with current electricity. What's current electricity? A steady flow of electric charge that move through a conductor in a controlled way. Like for example, say if I have a wire like this, right? I have a wire structure like this, and it's filled with the electrons. It's filled with electron, right? These are the carriers of the charges. These are the carrier of the current. Now, point is that these, when they start moving in one direction, all of them start moving in one singular direction, they will produce a net effect. Point is that initially, before applying the battery or before applying the potential difference, all were traveling in random directions. But when the potential difference has been applied, let's say here the potential difference is V and here the potential difference is 0. We know that since water flows from high pressure to the low pressure, similarly current also flows from high potential to the lower potential. And since this end is the higher potential, all the current will start flowing in this direction towards the lower potential. And this has to be in a controlled way, like a steady flow of electric charges that move through a conductor in a controlled way. Controlled way means how to control them? By applying, the flow of charges can be controlled, can be controlled by applying required potential difference. Potential difference. If I want the current to be flow in a very good speed and in a very high speed, obviously I'll have to increase the potential. Let's say if I increase the potential from V to 2V, the flow of current will increase. But if I want the current to be flowing in a very less speed, less speed, then obviously I'll have to decrease the potential. So now I have decreased the potential from 2V to say instead of 0, it has been 1. 1 to 0, very less potential difference, right? So here the current will flow in a very steady way, in a very slow pattern, right? Now this, as you can see over here, this is without any potential difference, and this is the case with potential difference. So whenever I apply the potential difference, the electron or the charges basically start moving in a fixed direction in a controlled way, right? But if there is no potential difference, if I have not applied any kind of potential difference, they all move randomly in a different direction with their different speeds, right? So the net effect produced by them will obviously be 0, isn't it? Right. Moving on, the next is conductor and the insulators. Conductors anticipate free flow of electric current because of the electrons roam freely from one atom to another with ease. Insulators, on the other hand, oppose electric current because they won't permit free flow of electron from one particle to another. Let's say that I have these two materials. So this is the first material. This is the first material. It's a metal plate, assuming it to be a metal wire or metal plate, possible. Now, instead of this, I have taken in the second case, I have taken this to be a plastic material, plastic wire, plastic wire, right? In the metal wire, there are a large number of free electrons, है ना? Many free electrons. But in the case of plastic wire, there are rare free electrons, rare free electrons. Now, since the plastic wire has contained a very less amount of free electrons, will it allow the flow to be happening properly? No, it won't, right? It won't allow the proper flow of electrons. But if it is a metal wire, it has large number of free electrons, है ना? The electrons just need a small amount of potential difference and they are now ready to move, right? So in that situation, if I have very less amount of free electrons, then obviously this cannot allow proper passage of the electrons. This will hinder the passage, the flow, study I can say, and this will allow free passage of electron. So that is why this can I can say that yes, wire are conductors because they have got free electrons, and so they are called conductor, which conduct electricity, and they are called insulators because they don't conduct electricity. They are called insulators, right? Clear? As you can see over here in this case, since it's not a wire, है ना? I mean it's the insulating ceramic. Here we have an insulating ceramics. There are no free electrons, and since they don't have any free electrons, so there is no charge carrier in this case. But whereas here they are, these are free electrons, isn't it? Free electron, and that's why they allow the passage of electrons easily, right? Next is electric current. See, electric current is denoted by the symbol I. Electric current is denoted by the symbol I, and I'll say that the flow of electric charges, or instead I can write it as rate of flow, rate of flow of electric. For any quantity, if I have this word rate written, I'll tell you something that if for any quantity, if I have the word rate written, that means the particular quantity will be divided by time if there is a word rate in the definition. That means if I write the formula of current, it will be current is equal to current will be equal to charge, electric charge, and charge is denoted by Q, charge, and since it has a rate word over here, so it will be charge divided by time. I is equal to Q by T. Next is this flow of electron in one direction in a circuit is called an electric current. Obviously, you can write this as the definition, or you can write this as the definition: rate of flow of electric charges. Then electrons require energy in order to move, obviously, and this energy is given by applying potential difference, potential difference, right? Next is energy come from the electric cell in the circuit. Yes, obviously, and electric circuits provide you with the potential difference. In general uses which we have in our homes, we have when we purchase electric cells, they are written 1.5 volt. 1.5 volt basically tells you the potential difference, you know, which can be applied by that particular cell. And then the cell has two terminals. They are symbolized like this. The larger one is basically the positive terminal. The smaller one is the negative terminal. These are the two terminals. And for the electric current, if I say yeah, unit of current, then it will be unit of charge upon unit of time, and unit of charge is coulomb time is second. So the unit of current can be coulomb per second, right? Or you can also say it in a common term, that is ampere. So for the units, we can either write it as coulomb per second or we can write it as ampere, right? These are the various components of the circuits. See, here we have here we have a switch which decides whether the current will flow or not. Here we have the bulb. So as soon as we switch on the current, say this is the positive terminal, so this will be the longer one. This is the negative terminal, so this will be the shorter one. So current starts flowing from here, here, here. So when the switch is on, and when the switch is on, current flows like this. As soon as it reaches the bulb starts glowing, and then current moves, moving on, and the current reaches to the negative terminal. This is how the circuit flows. Where this bulb will be represented by this, switch is represented by this. For this, you can represent it as like this, or even you can represent it as positive, negative. The circuit can also be represented in this manner. So if I say that for cell, the symbol is positive, negative terminal, that's it. For bulb, the symbol is, this will be the symbol, right? And then obviously we have the wires, right? So these are the diagrams. Obviously you just can understand that drawing this pictorial diagram is like a hectic thing. Instead of drawing this pictorial diagram, if I just draw it in the form of circuit diagram, this will be much easier for me to do so, right? So that's why we need this, correct? Common components are this, we have already discussed this. See, in making a battery, positive terminal of one cell is connected to the negative terminal of the next cell. Positive terminal of one cell is connected to the positive terminal of the next cell. Negative terminal of one cell is connected to the negative terminal. None of the above. See, basically in making a battery, what is a battery? Battery you can say that combination of cells. Combination of cells. So if I want to combine a number of cells, then it should look like positive, negative, positive, negative, positive, negative, positive, negative, and so on. So positive terminal of one cell is connected to the negative terminal of the another cell. See, this is positive and this is connected to the negative, correct? So yes, this is true. If I move to the other options, the positive terminal of one cell is connected to positive terminal of the next cell. See, is there any connection between positive and positive? No. Positive is never connected with the positive terminal, right? So that this is absolutely not possible. Negative terminal of one cell is connected to negative terminal of the next cell. Again, negative are again not combined, and none of the above. Obviously, one option is there, so option A will be the correct answer. Clear? Where can the key or switch be placed in the circuit? Left side of the battery, right side of the battery can be placed anywhere in the circuit near the positive terminal. Basically, if I have a circuit like this, try to understand that this is a circuit with a battery, and here I have a bulb like this connected via a wire like this, and say here I have the switch. Similarly, if I keep this switch instead of here, will it make any difference? Point is that we should not allow current to flow in the circuit anyhow. They should not be allowed to flow. And if I break the wire here, or if I break the wire here, if I break the wire here, in none of the cases, the current is going to flow in such a situation. So obviously, can be placed anywhere in the circuit. The other options are absolutely wrong, right? So this was regarding the introduction and the electric circuits. Like we studied the components, the circuit diagram, the symbols. What is current? We studied that, and conductor, insulator, obviously. Then we had the introduction part, right? So please make sure that you are properly revising them. Sure. Thank you.